Okey, so kita sambung sikit balik video tadi. Video tadi saya terberhenti sekejap sebab anak saya bangun. Okey, saya nak sambung still for parallel reactions with two reactant systems. For case number 2, in which alpha 1 is the value is higher than alpha 2, but beta 1 is lower. The value is lower than beta 2. So meaning that in this case alpha 1 minus alpha 2 is more than 0, but beta 1 minus beta 2 is lower than 0, because tadi beta 1 dia punya value lebih rendah daripada beta 2 kan. So kalau kita buat alpha 1 minus alpha 2 equals to A, so beta 1 minus beta 2 is equals to B. So meaning that B ni adalah value yang lebih kecil daripada 0. So for case 2, kita akan lihat selectivity dia akan jadi kalau awal kita tengok alpha 1 minus alpha 2, then CB beta 1 minus beta 2, but because alpha 1 minus alpha 2 is more than 0, beta 1 minus beta 2 is less than 0. So bermakna kalau kita transformkan dia dalam bentuk A and B, so CA to the power of A, because A is more than 0, so dia akan berada sebagai nominator. And for concentration B, beta 1 minus beta 2 ni adalah less than 0, so meaning that B is negative value. So bila negative value, dia akan jadi denominator. So for this case, in order to maintain high selectivity, what you need to do is you need to maintain high concentration of A, but you need to maintain the concentration B as low as possible. Okay, so you boleh tengok sendiri dia punya recommendation on how to accomplish high selectivity. So contohnya, you have to use the semi-batch. B is fed slowly. You can use also tubular reactor, and side stream dia adalah B. Kemudian you can use series small of CSTR, in which that the reactant is only A and small amounts of B to each reactor. So ini adalah cara untuk maintain high concentration of A and concentration B to be as low as possible. Okay, next case is untuk this case is alpha 1 minus alpha 2. Dia kata value untuk alpha 1 is less than alpha 2. So meaning that kalau alpha 1 minus alpha 2, dia adalah less than 0. Then beta 1 minus beta 2 is also less than 0. So katalah ni A, ini B. So dua-dua adalah less than 0. Bermakna selectivity dia okay. Ni saya buat panjang sikit sebab simplification dia ada dekat sini kan. Saya nak tunjukkan cara macam mana boleh dapat ni. So disebabkan yang ini dan ini adalah less than 0, so KD over KU, in which that CA is minus negative A, darab CB also minus negative B, in which that CA CB ni adalah dua-dua adalah denominator. So this one is A, this one is B. So meaning that in order for you to maintain high selectivity, you need to make sure both reactant A and B adalah as low as possible. Okay, let's have a look at next slide. So this is the recommendation. So you can baca sendirilah, like use CSTR, use tubular reactor, but large cycle ratio, you have to use diluted feed. So kalau gaseous reaction, you have to use low pressure. So ni semua adalah untuk maintain low concentration of A and B. Okay, next slide is in this case pula adalah alpha 1 minus alpha 2 less than 0. Sebab ni dia kata value for alpha 1 adalah rendah daripada alpha 2. Kemudian beta 1 minus beta 2 adalah lebih daripada 0. So meaning that this is negative A and ni adalah B. So bermakna you punya selectivity akan jadi, so I just cut it short, you akan dapat CB over CA. This is the order of B and this is A. So untuk case yang keempat, you have to maintain your concentration of B to be high but concentration of A to be low. So the suggestion, you boleh tengok dekat sini, you can use semi-batch reactor where A is fed slowly. You can use tubular reactor, side streams of A. Sebab apa? A, you have to make sure that A is to be low. Kemudian you can use series of small CSTR, but B to be fed first and then A to each reactor. So case 4 ni adalah dia terbalik dengan case nombor 2. Okay, kita akan sambung dengan next video.